Welcome to the lecture series of Hydrogeology. So today we are going to talk about land subsidence and impact of global climate change on groundwater. So I have merged these two topics actually because land subsidence is also a short topic and the impact of global climate change is also a very short topic which I need to discuss. So first we are going to discuss what is the definition of land subsidence, although from name itself you know that when ground is going to collapse, okay, but when this happens we are going to discuss the causes, and then we are going to discuss its association with hydrocompaction, and we are going to talk about its association with sinkholes, its association with dewatering of organic soils, because all of them are associated, lowering of the piezometric surface. So we are going to see that how all of them are related one by one, and we are going to see compaction and compression difference because of the land subsidence or because of certain factors which I'm going to discuss one by one. And then we are going to see that how you can monitor once you have figured out that you are in a region where land subsidence can take place. So what are the factors you need to take into account, or what are the parameters that you need to keep on monitoring so that you're aware that okay, now alert has to be issued because this ground is going to be collapsed. Okay, then after that what I'm going to do towards the end, I'm going to discuss that how climate change is causing or it is affecting the water storage pattern throughout the entire water cycle. Okay, so you know that climate change is happening and there are a lot of effects which we see, correct? But what are the effects on groundwater sustainability and how is aquifer sensitive to climate change? We are going to discuss that. Okay, so let's start now. Let's start by understanding the definition, the causes and concepts. Okay, so first of all I'll define for you what is land subsidence. So if this is the earth's surface and it gradually starts settling down or suddenly it sinks, why? Because of the movement of the material which is present beneath the surface. So if because of this you are facing any kind of activity, you will term it as land subsidence. Okay, so there are some causes of this subsidence. Now either you can attribute it to the aquifer system compaction, and in simple language if I have to say, that is whatever layers, underground layers are present, they start squeezing in. All right. Second, mining of groundwater. That means when you're pumping out the groundwater, that could also result into such a situation. Drainage of organic soil. This could be another factor. Then underground mining, hydrocompaction, sinkholes, thawing permafrost. If a layer, permanent, ice is present in a particular region and then it start melting from below, so then also it will start sinking. So that means there are various reasons for the land subsidence. So we need to understand them one by one. That if I'm referring to the concept of aquifer system compression, or let's say aquifer system compaction, now these are both because of the changes in the groundwater level. So what is the detail of it? We'll discover that one by one. Okay, so first if I start with the aquifer system compression, so this is a reversible change. Whereas if I talk about compaction, aquifer system compaction, this is a permanent change. All right, so we'll start with compression. So the changes, whatever are happening in the groundwater level, they are going to cause this aquifer skeleton to compress or to expand or compress. Now this is a new term for you, aquifer skeleton. What is it? Whatever solid rock or soil particles are present, I'm talking about that. That is what we are referring to as aquifer skeleton over here. Okay. Now let's say that the groundwater level has lowered. Now this is one situation. So when the levels are lowered, what will happen? The support which was previously provided, if let's say this is your rock which is present, so it is having some kind of pore fluid over here, and this is creating a pressure that is known as pore fluid pressure. So it is kind of providing you the support. Now let's say the groundwater has lowered. So whatever support was being provided by this pore fluid pressure, it is going to get transferred to aquifer skeleton. So because of that, the skeleton will compress. Okay. Now let's say opposite happens. By opposite, I mean the rise in the groundwater level is taking place. Maybe some recharge has taken place, and because of that, so that means the support is transferred back to the fluid, and at this time what will happen? The skeleton is going to expand. So you understood this thing, that entirely on the basis of groundwater level, how it is rising or falling. So we are going to decide what is going to happen to the skeleton. Now what will be the resultant of this? See, it is doing both the things, like back and forth deformation is happening. This is the correct terminology, back and forth deformation. This is completely recoverable, and I'm talking about all the aquifers. Okay, and they mostly result in seasonal reversible displacement in land surface. So this is one of the reason for your land subsidence. Second, if I talk about aquifer system compaction, I told you this is a permanent change. That means this is a not reverse. This is not going to get reversed. Here water level will change, recharge will happen, and you're again going to land up in the same situation, maybe compressed, maybe expanded. But what about the compaction one? So this is a more severe, or rather I should say the permanent process that occurs. Now what is the cause of this? Now water is actually forced out in this process from the fine grained layers into the aquifer. If I'm talking about fine grained layers, that means I'm referring to aquithards over here. Okay. So the maximum level of past stress a skeleton experience or a skeletal element experience is known as pre-consolidation stress. Okay, and let's say you are having this aquitard skeleton over here, and whatever load is present over here, it exceeds this pre-consolidation stress. So what is going to happen? Just think, you are having an aquitard, and on that aquitard, what I am doing, I am putting a lot of load. Now in real case scenario also, you can think I'm putting a lot of load on the aquitard, and this is far more greater than what, than the stress which the skeletal element is capable of bearing. Okay, the maximum level of stress. So in that case, that is so obvious that whatever is going to happen, the compaction, it will be irreversible. And what will be the result of it? There will be the permanent reduction of pore volume. Why? Because water has now squeezed out of the aquitard. Correct? All right. Now talking of lowering of piezometric surface. So where you are going to witness a heavy pumping from the aquifers, specifically from the confined aquifer, in those regions you're going to see that the land subsidence that is taking place, that is usually accompanied by lowering of piezometric surface. So they go hand in hand. Okay, so if I have to explain this now, so it is entirely based on the fundamental of soil mechanics. All right, so for that what you will consider these two diagrams which you see on the right hand side.